This is review number 2 for geometry in unit 2. In this video, I'm going to go all the way from numbers 1 through 6. So I'm going to look at all those problems in this video. Number 1, they give us this diagram, and they tell us that the measure of angle 1 equals 8x minus 40. Measure of angle 2 beneath it is 3x plus 95, and find the measure of angle 2. First, we have to recognize that these angles, there's angle 1 and angle 2, are opposite from each other. And when we have these angles opposite, these are vertical angles, which means they're equal. They have the same measure. So the first step we have to start with is 8x minus 40 equals the 3x plus 95. Then as we solve that, I'm going to subtract 3x. I get 5x. I'm going to add 40 to this side equals 135. And then I'm going to divide by 5, and I get 27. Now, the only trick here is that gives us the value for x, but it's not the measure of angle 2. So here they're asking us to find the actual measure in degrees. So to do that, we go back to angle 2, we take that 27 and we plug it back in. So it becomes 3 times 27 plus 95. 3 times 27 is 81 plus 95. Then we add these and we get 176. And the measure of angle 2 is actually 176 degrees. It's not drawn to scale, so it doesn't look like 176, but that's what we get when we plug in that x value. Number 2 asks us to describe a sequence of transformations that will carry A, B, C, D, E, F onto this A prime, B prime, C prime, etc., this new shape. Now, there's a ton of different ways you could do this. When they say transformations, they're talking about translations, which is the slide, rotations, which is the turn, and then reflections, which is the flip. Now, if you look at the way it's facing, what we want, I'm going to trace this first shape. What we want is we want all these letters, A, B, C, D, E, F, to match up with their corresponding ones. So in other words, A has to match up with A prime, B with B prime, C with C prime, and so on. So after I trace it, I'm going to try to start moving it. Now, if I do a translation, I could actually try translation. What I would suggest is when you move this over, try to match up the letter with corresponding letter on this side. So in other words, if I start with A, I'm going to concentrate on A. I want A to land on A prime here. So to do that, I can translate up 1, 2, 3, 4, 5 units and go to the right 1, 2, 3, 4, 5, 6, and I think I'm there. Yeah, 6 units. So I went up 5, right 6. Now see how A and A prime now are together. Then to get this down here, now to finally get this shape exactly onto it, I can rotate around point A, and when I do that, now I've got A, B, C, D, E, F, all of them matching up together nicely. Now that was 1/4 turn. That's a 90-degree rotation. Now again, there are tons of different answers that will work here, but what I started with was again translation up 1, 2, 3, 4, 5, and it was right 6. So here my answer is going to be translate up 5, right 6, and it was a rotation. It was rotate 90 degrees, and that when I was there at A, I rotated 90 clockwise, 90 degrees clockwise around point A, because that was where I put my pen when I turned it. I put it right on A, 90 degrees clockwise, got me there. Number 3, a little more simple. Number 3 is multiple choice. Which of the following is the definition of a right angle? We all know that a right angle is exactly 90 degrees. Here it says between 0 and 90. Here's exactly 180. Between 90 and 180, exactly 90. That's what I want. Answer D for number 3. Excuse me. Number 4, choose all that are examples of rigid motion. Remember, rigid is the kind of motion where it stays the same size. Non-rigid is where it gets either larger or smaller, either enlarges or reduces, but rigid stays the same size. And that was the original three transformations that we dealt with. Now part A, vertical stretch. A vertical stretch basically means that a shape is getting taller. So it's taking an original shape and making it taller. Translation, that's what I want, because translation doesn't change the size at all. Horizontal stretch is if I took this triangle and I made it wider. So that's a horizontal, which is not rigid. Reflection does keep it the same size, so reflection I want. Rotation keeps it the same size. And there's my three original transformations that are all rigid motions. Enlargement does not stay the same size, it makes it bigger. Reduction makes it smaller. So the ones I want are B, D, and E. Number 5, angle A and angle B are complementary if measure of angle A equals x minus 8 degrees and measure of angle B equals 3x plus 14 degrees. Find the measure of angle A. So if I compare it to number 1, again, find the measure of the angle. Same idea here. We have to solve for x first, and if we're finding the measure of angle A, we have to plug into this x right here. Complementary, we have to remember, means they have a sum of 90 degrees. Supplementary is 180, complementary is 90. So this is, again, sum of 90 degrees. So I'm going to take the x minus 8 plus 3x plus 14 and put that equal to 90. Now when I get here, once I set this up, now I'm trying to solve for x. I combine like terms here. And remember, combining like terms, I'm not changing any signs. I have 1x plus 3x is 4x. And then minus, I'm going to treat it like a negative. Negative 8 plus 14 is positive 6. Then I'm going to subtract 6 from both sides. I get 4x equals 84. I'm going to divide by 4, and I get x equals 21. And notice that 21 is not even one of my 4 answers there. So now I got to take that 21, I got to plug it in here. So for the measure of angle A, it becomes, instead of x minus 8, 21 minus 8. 21 subtract 8 is 13. So my answer is A, 13 degrees. Number 6 is another multiple choice. Asks if a triangle ABC is reflected across the y-axis, which of the following coordinates is the vertex of its image? Now what I could do is I could use a tracing paper, and I could trace triangle ABC. And usually whenever we trace the labeling as well. There's ABC. And I'm going to trace the y-axis, because that's what I'm reflecting over. And I'm going to put that little mark there, because when I flip over the y-axis, there's my reflection. That tells me I got to line it up. Remember, you're lining up the dashed line with that origin there in the middle. And they're asking only about which of these would be actually on this triangle. So if I look at the answer choices, I have negative 1 and 1. Negative 1 and 1, that is there, that's on it. Negative 4, 3, negative 1, 2, 3, 4, up 1, 2, 3 is not on the corner. 3, negative 3 is way off. 3, negative 3 is down here. 6, negative 2, same thing all the way down here. Now, that's one way, is using the tracing paper. We found that negative 1, 1 is the only correct answer. So that is our answer for number 6. You could also, if you wanted to graph these points, you could graph negative 1, 1, and you could graph negative 4, 3. 2, 3, 4, 1, 2, 3. And look at if it's got a mirror image on the other side of this y-axis. This is one step away. Same thing as this original point A, one step away. So that does work. So that is one of the ones that would work. And once you graph the other 3, it would see that, well, 3, negative 1, 2, 3 is way down there. 6, negative 2. That's over the x-axis, not the y-axis. And this point is 1, 2, 3, 4 away. 1, 2, 3, 4 away. It's not matching up with any of those 3 points. So a couple different ways you could have done number 6.